Hello, and welcome to this fifth and final film in the series of films about solutions. This one concerns itself with precipitation reactions, so the reactions where we make insoluble substances from a solution. And hopefully by the end of it, we will understand how it is that combining two solutions can result in the formation of a precipitate. Really importantly, you ought to be able to write ionic equations to show these things happening. And also you ought to be able to predict your observations. Now, hopefully this film won't be too long. There was another film about ion concentrations, I think, which ran a little bit over time. We'll get through this as quick as we can, but these ionic equations and observation skills really are very, very important. So I just want to make sure that they're covered in sufficient depth. Okay. First of all, why do precipitates form? Well, to understand that, we need to consider the solubility of different substances in water in particular. Okay, so if we look at here what's happening, we're mixing silver nitrate with sodium chloride. Now if you look up on your data sheet what the solubility of those substances is, you'll see that they're both soluble. However, in this solution we've now got sodium ions, we've got silver ions, we've got nitrate ions, and we've got chloride ions. Now we know that sodium chloride is soluble. We know that silver nitrate is soluble. We also know that sodium nitrate is soluble. But silver chloride, which is in our solution, it wasn't before we mixed the two things. Silver chloride isn't soluble. Silver chloride is an insoluble substance. So as soon as those ions come together, they'll basically form what is a supersaturated solution of silver chloride. There'll be more silver chloride in the solution than can dissolve. So it will crystallize out. In other words, a precipitate will form because the solution can't hold the silver chloride. Okay? Because it's an insoluble substance. Right. How do we predict what will precipitate? Well, I've just been referring to these things on the data sheet. It is vitally important that you use your data sheet. There's no need to try and remember these things. All the information you need is there. Okay? It looks a little bit like this. I wasn't able to cut and paste the exact table that you've got on your data sheet, but if we look here, it says that all group 1 metal compounds and all ammonium compounds are soluble. All nitrates and all acetates or ethanoates are soluble. All chlorides and bromides and iodides are soluble too, except for silver chloride and iodide and bromide, lead chloride, bromide and iodide, and mercury, and so on. Okay? What can be a little bit confusing is the way that they organize this table, because they put the insoluble compounds in the same column directly beneath the soluble ones. Okay, so look out for the insoluble compounds. There are exceptions. So hydroxides tend to be insoluble, but we know that all group 1 metals are soluble, and so are all ammonium compounds, so they must be soluble. And also calcium hydroxide and barium hydroxide are soluble. Okay, so just be a little bit careful how you use these tables, but they are there on the data sheet. There's no need to remember this information. Okay. Let's see if we can write an ionic equation for a precipitation reaction happening. Vitally important that when you write your equation, you don't write any ions that haven't reacted. We call them spectator ions, okay? And when you're doing your tests and your exams, they shouldn't appear in your equations. They can appear crossed out, but they shouldn't be left in there, okay? So let's have a look. Silver nitrate solution is mixed with sodium chloride. We've just seen that, okay? Here are the compounds, AgNO3, and again, you need to know your ion list, otherwise you're not going to be able to do these sort of questions. Right? So let's write down all the ions that we're mixing together. We're writing them as separate ions because these substances have dissolved. Okay? So these are both strong electrolytes. You put them in water, they split up into ions. Okay? So I'm mixing these ions together with these ions. All aqueous, although you don't need these state symbols in the exams and tests. It's just a good thing to include when you're thinking through the answer. Okay, If I look up on my data sheet what's soluble and what's not, well, I know silver nitrate is, I know sodium chloride is. What other possible things have we got? Sodium nitrate is also soluble, but silver chloride is not. So silver chloride will form a solid. Okay, that's our precipitate. And we're left over with the sodium ions and the nitrate ions that are still dissolved, or in other words, they're still aqueous. But remember, we're not going to include in our equation any ions that haven't reacted. So I'm going to cross out all the spectator ions here. And what you can see is you're left with an equation that shows you what ions go together to make this solid. So it should be quite a simple equation to write. You just, as long as you know the formula of the precipitate that's going to form, so as long as you can check on your data sheet which compound is going to be insoluble, once you know that formula, the equation writing, it should be quite simple because you're just writing the formula of the ions that go together to make this substance, okay? If you need to think it through and include all the other ions, just make sure you cross out the spectators at the end. You don't have to rewrite this equation without the spectators in it at all, okay? Some people can just do it straight away in their heads without the spectators. If you need to show them there as you're working and then cross them out, that's absolutely fine. Let's just have a look at another example. Okay, barium chloride, so that's BaCl2 mixed with sulfuric acid, H2SO4. Let's write down the ions that are involved here. That's a solution. All acids are solutions in water, as far as we're concerned. Okay, so we've got Ba2 plus ions. They're aqueous. We've got 2 chloride ions, 2Cl minus, AQ. Not a Cl2 minus ion. That's just made up nonsense, okay? Plus 2 H pluses here. All acids have H plus ions, and there's 2 of them there. There's no such thing as an H2 plus ion, okay? So SO4 2 minus is also there, and that's also aqueous. If we look up these new combinations, we could have, well, we could have HCl, that's strong acid, so that's going to dissolve. We could have, what else could we have? We could have, well, we could have BaSO4. If we look up sulfates on our data sheet, we'll see that they're insoluble, and barium, that they're mainly soluble, but barium sulfate is a notable exception. So that's going to form a solid, okay? And we're left with the ions that didn't react, 2H plus 2Cl minus, okay? So again, I might have just written the equation ignoring those altogether, but if I wanted to include them as my kind of thinking process, I can just cross them out afterwards. And we can see again that our precipitate here, so we decided what substance is insoluble by looking it up on the data sheet. That's just made from the ions that make it up. And that's what our equation is, if you imagine that the blue stuff wasn't there. Okay, moving on. Saying what you actually see happening. So this is predicting the observations of a reaction. Okay, we're going quite quickly here. Could well be that you'll need to practice this quite a lot and watch the film again, but here we are. A copper chloride solution is mixed with lead nitrate. Let's see what we've got. We've got Cu2, copper 2 chloride, that should really say, I suppose, CuCl2. We're mixing that with PbNO3. And there's 2 plus charge on the lead ion, so there must be 2 nitrate ions because they're a single minus. Once again, it's crucial that you know your ion formulas. Okay? Let's say what ions are all combining together here. So we've got Cu2 plus ion. He's aqueous. Okay? We've got 2 chloride ions, 2Cl minus, Aq. We've got a lead 2 plus ion, also aqueous, because these are solutions that we've mixed. 2 nitrate, 2 NO3. Now, let's look up the new combinations that we can see. Right, we could have lead chloride and we could have copper nitrate. Those things are different from what we started with. Okay, copper nitrate, like all nitrates, is soluble. So the copper 2 plus ions and the nitrate ions are going to remain in solution. Okay, but lead chloride is not soluble. Okay, so it's going to form a precipitate, PbCl2 solid. Okay, what have we got left to do here? Well, remember, we need to get rid of the spectator ions, those that didn't react. Okay, CuNO3 didn't react. So our equation is Pb2 plus 2Cl- makes this. Once again, our formula of our solid precipitate from the ions that made it up. Okay, now, saying what we see happening, we need to describe what we start with and what we end up. Let's look up the colours of all these things on our colour chart. Cu2 plus is a blue ion in solution, so we've got a blue solution. Chloride is colourless, lead is colourless, it doesn't appear in our colour chart. Okay, so is nitrate. So a blue solution altogether is mixed with a colourless solution. Right, because we decided that our lead nitrate was colourless and our copper chloride was blue. What are we ending up with? Well, if we just ignore all our spectator ions altogether, it might be a bit harder to see this, but they're still there in solution. So we're going to end up with a blue solution. And we can look up what this is. Well, if it doesn't have a coloured ion in it, our data sheet says we should presume it's white. Please read the information around the tables carefully. It is relevant to the tables. Okay, so we've also got a white precipitate. Some people just go, oh, white precipitate forms, but that's ignoring all the other stuff, right? I want you to try and get in the habit of describing everything that you start with and everything that you end up with when you're doing these. Okay? Now, even more so than with calculations probably, the key to getting reaction equations and observations right is practice. And when you finish practicing, you should probably practice it some more. If you're making mistakes or if you're finding it hard, you don't know how to write the equations, you should consider whether it's the formulas that you're getting wrong, whether it's the ions that you're forgetting in the first place, whether it's the fact that you're not using the data sheet right. Whatever it is, you need to practice it until you get it right. And if you don't know where you're going wrong, then please come and get some help with it. Okay, that's the end of the series of films about solutions. Okay, so good luck with that topic in your test.